The hydrography of Colombia is one of the richest in the world. The steep slopes of the Colombian mountains harbor a huge hydropower potential in its wrinkled slopes. Winding through forests, canyons, and fertile valleys, we find mighty rivers such as the Magdalena, Cauca, Atrato, Guaviare, Putumayo, and Caquetá, without forgetting the immensity of the Amazon River. These waters refresh this beautiful land and put the country in 7th place planet-wide as far as the availability of water resources is concerned. In Colombia, there are many areas that, because of their remoteness, are not linked to the national grid. The energy needs of these areas that are not interconnected, which are approximately 66% of the national territory, are served through the Institute of Planning and Promotion of Energy Solutions for Non-Interconnected Areas, or IPSE, which develops structural energy solutions with the use of clean energy sources for power generation, based on the efficiency of available natural resources of the different areas and that can be quickly replicated across the national territory. This is how the IPSE has implemented itself as an energy solution with minimal environmental impact with its small hydropower plants or micropower plants. These use the kinetic and potential energy of the water flow to generate electricity in remote areas and that have the water resource, as well as helping expand the installed electrical output for networks isolated from the national grid, successfully reducing dependence on hydrocarbons. An example of this are the micro hydroelectric power plants in the township of La Encarnación in the municipality of Urrao, Antioquia, El Salto Cupica in the town of Bahía Solano, Chocó, and El Salado Ecotourism Park in the town of Envigado, Antioquia, where the vast existing water supply is taken advantage of to supply power to these populations, and as in the case of the Ecotourism Park El Salado, to encourage educational processes as well. Micro hydropower plant La Encarnación. The municipality of Urrao, Antioquia is considered one of the municipalities with the most potential in water resources. It has streams, waterfalls, mountain lakes, and at least 10 rivers that descend mainly from the Frontino highlands and that offer the necessary conditions for the rehabilitation and upgrading of the existing micro hydropower plant. This makes it possible to supply electricity to the 124 users of La Encarnación and 2 nearby townships, Barranco and San Rafael, by harnessing the flow of the stream Quebradona, a tributary to the La Encarnación River. By means of a deviation channel, the flow enters the intake where a grid filters the water of debris and continues along the 3.1 kilometer long conduction channel through a natural land channel, an artificial concrete channel, and artificial fiberglass pipe, depending on the topography of the land. All of this is done to drive a flow rate of 240 liters per second to the cargo tank, then through a 16-inch pressure pipe in flow-tight fiberglass with a gross fall of 42 meters, allowing access to the powerhouse, where a Mitchell-Banky or cross-flow generator is installed, where a 55 kilowatt capacity is delivered to the substation. Once the waters go through the turbines, they return through an artificial discharge channel to La Encarnación River. The substation is a conventional gravel-covered courtyard. It has a bank of 3 37.5 kilovolt single-phase transformers. It also has a 13,200 volt aerial network with 10-meter wood post supports and a cable length of 11.9 kilometers at medium voltage and 7.5 kilometers at low voltage. Cupica Falls Micro Power Plant. The Colombian Pacific Coast is considered one of the regions with highest densities of life forms per square kilometer. It has one of the highest concentrations of species of flora and fauna, and it is an area with one of the highest precipitation levels in the world. This prodigy originated 12.7 kilometers uphill in a rugged landscape of the Serranía de los Altos, with a micro hydroelectric power plant for the 1,650 inhabitants of Cupica. It uses to its advantage the Cupica River Leap, with a waterfall of more than 60 meters, which rotates a Mitchell-Bankey-type generating unit and produces 4 times more energy than the entire town needs today. Ironically, the Cupica River was seen by the local inhabitants more as an executioner than an ally, since one night in November 1999, its waters furiously overflowed and tore through the village, forcing its relocation and reconstruction. The IPSE is currently using the flow offered by the river in Cupica to supply electricity to 235 homes inhabited by approximately 1,650 people in the village of New Cupica and 50 users of the village Cacique. Sculpted from hard rock, we find the deviation channel, the water intake, the debris filter grills and gates to adjust the flow directed toward the metering or regulation chamber, which is a concrete structure 2 meters in diameter, with a lateral weir, gate valve for washing, and a 24-inch valve for output flow control. The cargo tank, a concrete structure consisting of a buffer and distribution zone, 2 grit chamber tanks, and the cargo tank, plus excess weirs and a sluice. Thus, free of debris and impurities, the water flows through a pressurized pipe to the powerhouse, which contains a 300 kilowatt turbo generator with a Mitchell-Bankey crossflow type turbine that functions at a speed of 575 RPMs, a multiplier with a speed ratio of 1:3, and a 400 kilowatt generator at a speed of 1,800 RPMs. On one side of the powerhouse is the substation, equipped with a 500 kilovolt transformer, which increases the voltage level of 480 volts to 13,800 volts. Connected to a 12.5 kilometer power line at 13.2 kilowatts, supported by fiberglass posts between the El Salto and the village of Cupica Bay. It is a distant municipality on the Colombian Pacific coast that, thanks to the IPSE, now enjoys electricity 24 hours a day, which becomes a cause for joy. Because the river that once destroyed the town of Cupica is now their new energy source. Tourist Park El Salado. The hydroelectric generation of electricity carried out by the IPSE at the Ecotourism Park El Salado in the municipality of Envigado, Antioquia, is designed to fully meet the electricity demand of the park, taking advantage of the Ajurá stream flow by driving a turbine generator group and thus producing the energy needed for operation, making it a model of hydraulic power generation for educational purposes, which is intended to help implement and teach about the use of these clean energies through the construction of an observatory for renewable energy in the country, which encourages research and technology transfer. The little power plant will feature the installation and operation of a 12-kilowatt three-phase turbine generator group, including civil works, water intake, causeway, powerhouse, and electromechanical equipment. The small hydroelectric power plants implemented by the IPSE divert water directly from its natural course without damming large volumes of water. The structures are small, of extraordinary simplicity, and they use a minimum amount of land. The most important objective in developing this type of project is the self-sufficient generation of electricity through the use and exploitation of renewable energy generated by a water resource. Thus, it seeks to create greater prosperity and better living conditions for populations where the IPSE intervenes. The importance of implementing alternative systems for power generation is to allow optimal management and utilization of natural resources, facilitating rational and efficient use of energy, mitigating environmental impacts, and above all, a significant decrease of investment costs. Hence, the pressing need to proceed with the IPSE's function, enabling many research groups in the country to run projects for innovation in alternative energy generation in remote areas that ensure their social, economic, and equitable development. IPSE. We integrate Colombia with energy.